All right, so we're going to start out talking about proofs, and specifically we're going to start nice and easy with something called an algebraic proof. But first, we need to know that a proof is an argument that uses logic, definitions, properties, and theorems to show that a conclusion is true. An important part of writing a proof is giving justifications to show why every step is valid. So we're going to go write down some algebraic justifications. These are some reasons that we do some of the things we do in algebra. Okay, the first one is called the addition property of equality, and it says if A equals B, then A plus C equals B plus C. And so as we're writing these, I want you to think about what they mean and where you might have seen them for. What this says is if you have something on one side of an equal sign and something on the other side, you can add the same things to both sides and everything still stays equal. And you know that because that's how you solve equations, is you add something to both sides of the equal sign. Our next one is a subtraction property of equality, and it says if A equals B, A minus C equals B minus C. And this is just like you're familiar with. If you have something on both sides of an equal sign, you know that you can subtract the same things from both sides. So hopefully these are not too difficult to comprehend. Multiplication property of equality. If A equals B, then A times C equals B times C. Again, both sides of the equal sign, you can multiply both sides by the same thing. Division property. If A equals B and C is not equal to 0, then A over C equals B over C. Again, equal sign, you can divide both sides by the same thing as long as that same thing is not 0. All right, now we'll get into some new ones that are still pretty basic stuff, but hopefully they'll make sense. The reflexive property of equality, and these are ones you're really going to want to learn. Reflexive, symmetric, and transitive. They're similar, but they're also very different. So the reflexive property of equality says that A equals A. And I know that may seem pretty basic right now, but it'll come up pretty regularly. So it's just good to know that something always equals itself. Okay, the symmetric property of equality says that if A equals B, then B equals A. Again, not very complicated, but it'll come up, and it's important to know the difference between reflexive and symmetric. The third is transitive. Transitive is a little bit different, and the transitive property of equality says that if A equals B and B equals C, then A equals C. So it just says if something equals something else, and then that thing equals something else, well, the first thing equals the last thing, and A equals C. Okay, substitution property of equality. This one's kind of long, so we're going to write it a little smaller. It says if A equals B, then A may be replaced by B in any equation or expression. And that's just like when we find out what x equals, right? We find out x equals 2, well then we go plug 2 back in everywhere there's an x because we're substituting it. Okay, distributive property you know well. It says A parentheses B plus C equals AB plus AC. And hopefully by this point you know that that's because the A gets distributed to both things within the parentheses. And the last one is combine like terms, which is something you know, but we're going to use it a lot just because it comes up a lot in algebraic proofs. So it just says A plus B equals 2A plus 2B. or 3 A's would make 3A, or 4 A's would make 4A. So you know that one already. All right, we're going to do a quick example of it. We have a problem here that says prove that if, so this is a conditional statement, if 4m minus 8 equals negative 12, then m equals 1. So this is our P and this is our Q. And we're going to prove it, and we're going to write a justification for each proof. So the first thing we see is this 4m minus 8 equals negative 12. Well, that's our P, that's our hypothesis. So that's given to us. We just say that that's given. Now we're going to solve this like we do any equation. We're going to add 8 to both sides. So then we're going to wind up with 4m equals negative 4. And the way we did that was we added the same thing to both sides of the equal sign, which means we used the addition property of equality. Okay? Then the next step we do is we divide both sides by 4, and we get that m equals negative 1, which is what we were supposed to prove. And the last step we did was the division property of equality. Okay, so example 1 that we just did right here, this is a proof. This is your very first proof. It's a proof of the conditional statement. If 4m minus 8 equals negative 12, then m equals negative 1. So notice the left side over here is the step-by-step process, and the right side over here are the reasons that we were able to do each of these things. And so most of the proofs we do are going to be called two-column proofs, and a two-column proof contains statements and reasons organized in 2 columns just like we did. Okay, in geometry, the reasons can be definitions. Okay, they can be theorems, postulates, or something called axioms, which we've also had a few of already. There's always 2 things that every proof is going to have. They're going to have given, that's the information provided, and you just accept that it's true. And then we're going to have the prove. And that's the statement or conjecture that you're going to prove to be true, or you're going to try to prove. Let's do another example. We have prove that if negative 2x plus 14 equals 10, that's our P, then x equals 2, that's our Q. So the first step in every single proof that you ever do is to write down the given information. So we're going to write negative 2x plus 14 equals 10. And our reason for that is that it's given information. Now we're going to start to do our steps. Well, you know the first step is subtract 14 from both sides. And notice I'm going to write all of this in this one box. So when I subtract this 14, this gives me negative 2x equals negative 4. And my reason for doing this step right here is the subtraction property of equality. And I'm sure you know the next step will be to divide by negative 2. And so we get that x equals 2. Still going to put a box around it because that's my answer. And my reason for being able to divide both sides by negative 2 is the division property of equality. So there you go. That's algebraic proofs. You have done your first proofs.